Now, one question from Alex. What if you touched the sun? Alex, listen carefully, because this question never gets old. It pops up in comment sections like a spark in the dark, and for good reason. It sounds simple, but it holds a doorway to some of the most extreme truths in the universe. You see, the sun isn't just a glowing ball in the sky. It's a nuclear cathedral, a star so vast it could swallow 1.3 million Earths. And yet it hangs there, 93 million miles away, feeding life like a silent god. We owe everything to it, the breath in your lungs, the food on your plate, and still we barely understand its wild heart. But what if, just for a split second, you reached out your hand and touched it? Would you feel heat first, or pain? Would your skin burn like paper, or would you vanish so fast that your brain couldn't even form a scream? Here's the twist. The answer is stranger than you think. Because the sun doesn't play by the rules of a campfire or a stove burner. It's not solid. It's plasma, a raging ocean of charged particles, so hot that atoms themselves are ripped apart. At its surface, the temperature is 5,500 degrees Celsius, hot enough to melt steel like butter. But its heart, it seethes at 15 million degrees Celsius, a heat so unimaginable that burning isn't even the right word. This isn't fire, it's raw nuclear fury, turning 600 million tons of hydrogen into helium every second, releasing energy equal to billions of hydrogen bombs going off in unison. So, Alex, you're about to hear what would really happen if you touched the sun. And I promise, it's not what you expect. But before we drift off into the heart of the sun, I have a question for you. How does my voice make you feel as you're falling asleep? Calm, curious, maybe just a little uneasy because we're about to step into something that feels like science fiction, except it's real. And while you're here, do me a favor. Drop a what-if question you've always wanted answered in the comments below. Something wild. Something that keeps you up at night, staring at the ceiling, wondering if the universe is even stranger than your dreams. Because chances are, it is. Now, let's make you comfortable. You're in a space where curiosity rules, where questions like, what if you touched the sun aren't laughed off? They're embraced, explored, and turned inside out until we uncover the truth together. Think of this as your midnight voyage through the cosmos, guided by someone who's as fascinated by the stars as you are. Here, we don't just throw facts at you. We tell stories that bend time, that carry you to the edge of what's known. So grab that blanket, sink deeper into your pillow, and listen closely. Because in the next few minutes, you're going to see the sun in a way you've never imagined. And trust me, you'll never look at that golden disk in the sky the same way again. Tonight's question isn't just about heat. It's so much bigger than that. It's about survival, physics, and the ultimate limits of matter itself. Because listen, when you talk about touching the sun, you're not just asking, what happens if I touch something hot? No, you're stepping into a realm where temperature, energy, and reality behave in ways your everyday experience cannot prepare you for. The sun isn't some campfire in the sky. It's a nuclear titan, a 4.6 billion-year-old engine that converts 600 million tons of hydrogen into helium every second, releasing energy so immense that a single second of its output, about 3.8 times 10 to the power of x to the third power, could power our entire planet for 500,000 years. Wrap your mind around that for a second. And here's where it gets even wilder. We're going to uncover its true nature, the layers you've never seen, the invisible storms raging above its surface. Storms that make Earth's hurricanes look like ripples in a pond. We'll explore how close humanity has ever dared to get, and what happens if you push just beyond the edge of safety, into a place where plasma rages at millions of degrees, where magnetic fields twist and snap with more force than 1 billion nuclear bombs. By the time we're done, you'll understand why this question, what if you touch the sun, isn't just impossible. It's one of the most fascinating thought experiments in all of science. So hear me carefully, because what you're about to learn will forever change the way you look at that blinding disk in the sky. After tonight, the sun will never feel like just sunlight on your skin. It'll feel like a doorway to something far more powerful and far more dangerous. First, let's clear something up. The sun isn't a solid ball of fire. That's a comforting myth from childhood, the kind that fits on a piece of notebook paper with orange crayons and smiling faces. But listen closely. The truth is far stranger and far more powerful than anything your imagination has yet dared to touch. If you could somehow cradle the sun in your hands, like a giant orange in the darkness, and try to peel back its glowing skin, you'd find nothing solid at all, just endless layers of plasma. Plasma is what happens when matter is stripped bare. Atoms torn apart, electrons ripped from their orbits, leaving behind a soup of charged particles swirling in a frenzy of unimaginable heat. Fire is child's play compared to this. This is a living ocean of electricity and energy burning in every direction at once. And the size. Oh, you need to hear this. The sun is so immense that over 1.3 million Earths could fit inside it. It is the tyrant of our solar system, a golden monarch that holds 99.86% of all the mass in our cosmic neighborhood, bending planets and comets into loyal orbits like servants circling their king. That blazing sphere, 93 million miles away, doesn't just sit in the center. It dominates everything. Without it, Earth is nothing more than a frozen rock in eternal night. Now, you might be wondering, okay, but how hot is it really? Listen closely, because this is where the story becomes almost unreal. The surface, called the photosphere, glows at about 5,500 degrees Celsius. That's nearly 10,000 degrees Fahrenheit. That's enough to turn steel into shimmering liquid in an instant, to reduce every element you know into dust. But deeper, oh, listen carefully here. The core roars at 15 million degrees Celsius. 15 million. At those temperatures, heat is no longer something you feel. It's an unstoppable force, a realm where hydrogen atoms slam into each other so violently they fuse, unleashing energy that powers all life on Earth. Every second, the sun converts 600 million tons of hydrogen into helium, releasing energy equal to 10 billion nuclear bombs every second. And yet, here's the twist that bends every rule you think you know. The corona, the sun's outer atmosphere can reach 1 to 3 million degrees Celsius, far hotter than the surface below it. Think about that. If you move away from the sun's body, you'd expect things to cool down, right? Like stepping away from a fire. But the sun defies logic. It burns hotter the farther you go, as if space itself is on fire. Why does this happen? That question has haunted scientists for decades. But hold that thought. Before we dive into magnetic mysteries and waves that ripple through space, I need you to picture something, because this is where the question gets personal. Forget theory for a second. Forget numbers. Imagine you could reach out with your own hand just once and touch the sun. What would happen to you in that instant? Now listen closely, because this is where the sun laughs in the face of everything you think you know about heat. Here's the paradox that has haunted solar science for decades. Why is the corona, the sun's outer atmosphere, hundreds of times hotter than the surface beneath it? Logic says the farther you move from a heat source, the cooler it should get. Like walking away from a campfire, the warmth fades with distance. But the sun, it plays by its own rules. Its visible surface, the photosphere, simmers at 5,500 degrees Celsius, 9,932 Fahrenheit, already enough to melt metal in an instant. But step into the corona just above that surface, and suddenly the temperature skyrockets to 1 to 2 million degrees Celsius. That's like standing near a candle and somehow getting hotter as you back away from the flame. What's going on here? One leading suspect is something called magnetic reconnection. Picture the sun's magnetic field as an ocean of invisible threads, twisted and tangled by the churning plasma beneath. Every so often, these lines snap and reconnect, like giant rubber bands breaking and lashing back together. When that happens, energy explodes outward, dumping unimaginable heat into the corona. We've seen this process trigger solar flares powerful enough to release energy equivalent to billions of hydrogen bombs in seconds. But that's not the only theory. Enter Alphane waves, mysterious ripples that travel along those same magnetic field lines, carrying energy outward like invisible tsunamis. As they crash into the upper layers of the sun's atmosphere, they deposit that energy, superheating the plasma in ways we're only beginning to measure. And here's where it gets exciting. NASA's Parker Solar Probe is flying straight through this puzzle. It's literally dipping into the birthplace of these waves, then magnetic storms, sending back data that might rewrite physics textbooks. But listen carefully. This isn't just trivia for stargazers. Understanding this mystery matters because when the sun's magnetic tantrums erupt, they can fling coronal mass ejections toward Earth. Massive clouds of charged particles traveling at millions of kilometers per hour. A single, well-aimed solar storm could fry satellites, cripple GPS systems, knock out power grids, and even disrupt the global internet for months. The last time Earth took a direct hit of that magnitude was in 1859, the Carrington event, and it set telegraph systems on fire. Imagine that today in a world run on electronics. So yes, touching the sun might sound poetic, but even from 93 million miles away, its anger can touch us first. Imagine this for a moment. You're drifting in the endless black of space, weightless, silent, suspended like a grain of dust in an infinite void. And ahead of you, there it is, the sun, but not the gentle disk you see from Earth. This is the sun unveiled, a raging titan 1.4 million kilometers wide, radiating so fiercely that darkness itself recoils from it. A golden inferno, so bright it burns away every notion of shadow. You reach out your hand, slowly, almost reverently, toward that glowing god, and then contact. But listen closely, because the truth will chill you. You'd never feel it, not for a heartbeat. You wouldn't live long enough for the nerves in your fingertips to whisper to your brain. Because at the sun's edge, about 5,500 degrees Celsius on the photosphere, and soaring to millions of degrees in the corona, heat becomes more than pain. It becomes an executioner that works faster than thought. Your atoms, yes, the very particles that make you, would betray you instantly. They'd start breaking apart the moment they tasted that heat. Think about butter on a skillet. It melts in seconds. Now replace that skillet with something 600 times hotter than a crematorium furnace, and you start to understand. Your skin wouldn't burn. It would vaporize in less than a millisecond, transformed into a scattering of ions and electrons before you could even blink. But wait, here's what's worse. You wouldn't even get that close. Long before you touch the sun, invisible forces would unmake you. Radiation, streams of extreme ultraviolet light and gamma rays, would slice through your DNA like scissors through silk. Then comes the solar wind, a hurricane of charged particles hurtling at 400 kilometers per second. That's nearly 1,000,000 miles per hour, stripping electrons from your atoms like leaves in a storm. To you, it would feel like an invisible ocean of fire gnawing at your existence long before your hand neared that blazing surface. But let's imagine, because curiosity thrives on impossibility, that somehow you survive all of this. Your body shielded by some miraculous technology, your atoms held together by defiance itself. You press forward. Finally, your fingertip brushes the sun. And here's where reality turns strange. There is no surface. The sun is not solid. It's an endless sea of plasma, a boiling storm of charged particles, twisting and roaring under the grip of magnetic fields so powerful they can stretch millions of kilometers into space. You wouldn't stop. You'd sink like a stone falling through fog, except this fog burns at 1,000,000 degrees and churns like an angry ocean. Down you go, into a realm where up and down cease to matter, where matter itself seems to dissolve into light. And then listen closely. Before you vanish completely into that nuclear heart, something extraordinary happens. The light from your final moment begins its journey. Traveling at 300,000 kilometers per second, it races across the dark emptiness, carrying the story of your last touch. 8 minutes later, it reaches Earth. Somewhere, sunlight glows on someone's face, and in that golden warmth is your ghost. Isn't that haunting? That even in death, you become starlight. Now, listen closely, because we're about to step into pure imagination. What if somehow you could survive it? What if your body could endure the impossible heat, the radiation, the crushing energy of the sun? Imagine it. You drift closer, past Mercury's orbit, where sunlight is 10 times stronger than on Earth. Shadows vanish. Darkness itself feels like it's retreating. Ahead of you looms an ocean of fire, except it's not fire as you know it. It's plasma, a churning sea of electrically charged particles, hotter than any furnace on Earth. And you are about to dive in. First, you'd pierce the corona, that ghostly halo we see during solar eclipses. It looks delicate from here, like a white mist. But don't let that fool you. It rages at over 1 million degrees Celsius, hotter than the sun's surface by a factor of 200. Strange, isn't it? That mystery we talked about, the heat rising as you move away, would be your first taste of the sun's paradox. Then you'd slip through the photosphere, the layer that shines like a golden skin to our eyes. It's cooler than the corona, at about 5,500 degrees Celsius, but cool only in name. At this point, Earth's hardest metals, tungsten with a melting point of 3,422 degrees Celsius, wouldn't just melt. They'd boil into vapor like a puddle on a skillet. Keep going, and the world changes in ways your senses can't follow. Beneath the photosphere lies the convective zone, a realm where plasma churns in titanic loops, carrying heat upward like boiling water in a pot the size of 1,000,000 Earths. Each bubble of plasma here, it's so vast it could swallow continents whole. And deeper still, you'd find the radiative zone, where photons take thousands, sometimes millions, of years to escape, ricocheting endlessly like prisoners in a labyrinth of light. Finally, you'd reach the core, the sun's beating heart. Here, at 15 million degrees Celsius, hydrogen atoms smash together so violently, they transform into helium, releasing energy through nuclear fusion. Every second, the sun converts 600 million tons of hydrogen into pure energy, a process so relentless it floods space with 3.8 times 10 to the power of the sun's watts, enough to power all of human civilization for 10 million years in a single second. And listen, if you were there in this heart of fire, you'd see no light as we know it. You'd be wrapped in darkness, because photons can't escape freely. All you'd feel is pressure, 250 billion times Earth's atmospheric pressure, and the weight of a star crushing down on you from every direction. Could you survive that? No. Not even in a dream. But imagining it brings you closer to understanding the sun, not as a distant disk in the sky, but as the very engine of existence. And now hear this. The same nuclear furnace that could unmake you in an instant is the reason you're alive to wonder about it. The warmth on your face, the spark of every green leaf, every ocean current, every breath. You owe it all to this impossible star. Now you're thinking, okay, humans can't touch it, but have we ever come close? Oh yes, and listen carefully, because this is one of the most audacious stories in human history. In 2018, NASA launched a spacecraft with a mission so bold, it almost sounds like science fiction, the Parker Solar Probe. Its goal? Not to orbit safely from a distance, but to dive into the sun's atmosphere, the corona, and taste its fire. But how close is close? By 2025, Parker will skim just 6 million kilometers from the sun's surface. That's 7 times closer than Mercury, our innermost planet, and far closer than any probe has ever dared. At its fastest, Parker will race through space at 700,000 kilometers per hour, fast enough to lap Earth in under 4 minutes. Think about that speed for a second. Now you're asking, how does it survive? That's where human engineering shines. The probe carries a carbon composite heat shield, just 11.4 centimeters thick, yet it holds back temperatures of nearly 1,400 degrees, 5,500 Fahrenheit on the front side. Behind that shield, the instruments stay at a relatively calm 30 degrees Celsius, about room temperature. Imagine standing behind a thin wall while a volcano erupts inches away and walking away unharmed. That's Parker. And what has this brave little spacecraft given us so far? Everything. It's uncovering why the sun's corona is mysteriously hundreds of times hotter than its surface, millions of degrees compared to 5,500 degrees at the photosphere. It's listening to the solar wind, a stream of charged particles blasting through space at over 1,000,000 miles per hour, learning how and where it accelerates. And it's peering into the sun's magnetic fields, those invisible threads that snap and twist, releasing bursts of energy equivalent to billions of nuclear bombs in a single solar flare. But hear this, Parker will never land. No probe ever will. And the reason is beautiful in its impossibility. To land on the sun, you'd have to do something harder than leaving the solar system. You'd need to cancel the Earth's orbital speed of 107,000 kilometers per hour to fall straight inward. That demands more energy than escaping Earth, Mars, and Jupiter combined. It's like trying to stop a bullet mid-flight by catching it with your teeth. And even if you could stop, the sun offers no solid ground, no surface to plant a flag, no soil to stand on. It's a storm without a floor, a sea of plasma where touch doesn't exist. You can't walk on sunlight. You can't hold fire in your hand. Yet Parker keeps flying, inching humanity closer to the star that gave us life, so we can finally learn its language before it decides to speak in storms that reach Earth.